Hello, everybody. It's great honor for me, and it's my great pleasure to give a presentation for 7 universities of Uzbekistan. And I'm very thankful to Lars and to all staff members for giving me such a chance. Also, I'm very grateful to Abror Gadayev as our Uzwater national coordinator, because he forced us to, while in Poland and in Sweden, he forced us to do a presentation on Aral Sea. So I have some kind of experience on having such presentation. Okay. Has it changed? Okay, I would like to begin my presentation with the saying of Ksanov, who was a master of Aesop, very famous ancient Greece fabulist, and the Latin word mare inter bibere, which means drinking a sea, which means actually making impossible. Actually, while drunk, he promised to his friends to drink a sea, but which was, of course, at that time impossible. But the next day when his friends or people came and asked him to drink a sea, he got lost. But Aesop actually advised him, okay, to say just, yes, I promised and I will drink a sea, but I didn't promise you to drink the all flowing rivers, the waters from rivers. So take away the all rivers and I will drink a sea. That's exactly the same situation as happened to Aral Sea, I think. It's taking away two main rivers, Amudarya and Sirdarya, caused the crisis of the Aral Sea. So name roughly translates as a sea of islands, referring to over more than 1,000 islands that had dotted its water. I am talking about this sea. And if we look to the history, we can see that the level of the Aral Sea level changes. It actually appeared 20,000 years before, but it changed a lot. Its level changes a lot, several times actually. Even in the 15th century, it was not the whole, didn't exist whole Aral Sea yet, but from since the beginning of systematic observations, which begins with 19th century and until the middle of the 20th century, mid or 50s or 60s of 20th century, the level of the Aral Sea has practically not changed. In the 50s, the Aral Sea was the fourth largest lake in the world, occupying, as you see, 68,000 square kilometers. Its length was 426 kilometers and with a width of 284 kilometers. The greatest depth of the Aral Sea was 68 meters. Actually, it was not so deep, but shallow, rather shallow sea. Okay. You see here, for comparison, it was, it's of course much, it's given the numbers for comparison. It was actually it's occupies you know, 1/8 maybe of territory Uzbekistan occupied actually, in comparison with the territory of Uzbekistan. It, of course, the biggest sea, inland sea, is the Caspian Sea, which is several times bigger than Aral Sea. Even. So he is given for comparison. So formerly the fourth largest lake in the world with an area of 60. You see how it dried up. The last picture is from 2006. You see that even the east part of the sea of Aral Sea, it's dried up totally, and now that place we call it Aral Kum, or which means Aral sands. So there are two actually approaches to understand to explain why it happened. The first approach is widely known approach is mismanagement of water resources. So from 1960 to 1990, during the 30 years, the area of irrigated land in Central Asia increased from 4.5 million to 7 million hectares. The water needs of the national economy of the region have increased from 60 to 120 cubic kilometer, which was the whole flow of two rivers. So whole flow to Aral Sea in 60s. So of which, of course, 90% is used for irrigation, where the water diverted for irrigation was often used inefficiently. So also during these years, happened to main water intakes from first of them happened in Fergana in 1939, for example, Great Fergana Valley, a Great Fergana Channel was constructed, digged up also by farmers, Tajik and Uzbek farmers were collective farmers actually of the Soviet Union is that channel was completed in 45 days in 1939. And second one, great water intake. That was the first one, Fergana channel was used for irrigating of Fergana Valley. And the second one happened here, you see, it was a Karakalpak channel, which happened which was finished in 1956. So that nowadays people say even not Turkmen channel, but Turkmen river, even with a length of 1.5 thousand kilometers. You have to understand the whole territory which is irrigates, it's deserts, so the water goes, you see the level, you see the Karakalpak channel, how it goes to the desertous places. Here is some images of you see the Great Fergana channel also here, how it so also cotton and wheat are watered along the irrigation ditches. Even wheat does not grow here without watering. We have to, you see from the pictures how inefficiently was used water resources. So it's also cotton, wheat, and rice, especially rice uses a lot of water. So that time in the 1980s, even our Uzbekistan produced 6 million tons of cotton. Also a lot of and other agricultural products. Here you see the table of how it's from 1990 in English till 2018. Also, I could find from internet the same numbers from 1960 till 2014. Actually, in the beginning of 90s, the Aral Sea, as you saw from the picture, it was divided to two parts: North Aral Sea and Big Aral Sea, south, which is, and you see what happened to the how changed its level of the sea from 56 till 26 in North Aral, the absolute level of the surface of the sea. And the saltness also, how it changes, for example, from 10 promille till 100 and 150 in 2014 in a Big Aral. So that was the first approach, which means misusing of water resources. And the second, there are of course secondary approach, which also says it's a which is also connected with a human activity, but it says that according to some estimates, earlier the Amud area along the Uzboy and Arm flowed into the Caspian Sea and the Turgay River into the Aral Sea. You see, from Turgay River flowed to Aral, then the sea. But Amud area flowed from Uzboy, Arm flowed to the Caspian Sea from this side. That's the reason for that, because it was found unique for Caspian Sea shellfishes, Cardium edule, were found in Aral Sea regions. That's people say earlier they were interconnected Caspian and Aral Seas, but some scientists say that first it was from Siberian rivers or Turgay river flow to Aral Sea first, that Cardian edule shellfishes were been in Aral Sea, and then they moved to Caspian Sea. So it's controversial approaches. Also, underground connection of the waters of the Aral and the Caspian Seas can be carried out under the Usturt Plateau through the karst voids in Miocene carbonate sediments and permeable aquifers in heterogeneous sediments of different ages. So second approach says because a lot of underground nuclear explosions happened in around the Aral Caspian regions, it forced to move all Aral Sea from because of gas and oil happened Soviet management, you know, there happened a lot of underground nuclear explosions to get the gas and oil. So from that graph, you see that during the 1970 till 1990, all the water went down like, you know, like whirlpool in a basin, maybe. Some scientists, they don't believe that it would happen during the 20 years or to all Aral Sea evaporated. They don't just believe, they say just some of waters were transferred to Caspian Sea or fulfilled the empty places of where formerly been gas and oil. So because of that nuclear explosions, for example, which proves the level of Aral Sea, it's in comparison with the Caspian Sea. During the 1970s, it went down 80 centimeter per year because the level of Aral Sea during the 20 almost years, and at the same time from mid of 1970s till 1990s, the level of Caspian Sea rised 32 centimeters per year. So some scientists, perhaps Golubev from Academy of Sciences, he says it's shown the underground nuclear explosions in the Aral Sea regions and the depths where it happened, explosion powers, magnitudes. Some says it's affected to that. As a result, water from Aral Sea went to maybe perhaps to Caspian or other places. So here is shown the place where that all and nuclear explosions happened in this region. It's Üstürt Plateau. So you see the level of the Aral Sea here, and which is higher than Baltic Sea. It's and shown the possible ways how Aral Sea waters went to Caspian, which level is below the Baltic Sea level. So, because Labnor Lake, for example, in China, Xinjiang Uyghur Autonomous Region of China dried up. It's of course a smaller river, lake actually. Also it dried up because of the same underground nuclear explosions in which happened in China. Also, Lake Chagan has dried up at the Semipalatin state site of nuclear explosions. So the argument for that second approach. So to say the consequences, I would like just to show some pictures, which is of dust and salty storms happens nowadays in our region. So so it's some pictures. It's nowadays even in Tashkent happens such dusty storms, which is 1,000 kilometers away from Nukus. Also, drying up of the sea has affected the climate of the region directly adjacent to the former sea area, which has become more continental. Summers have become drier and hotter, winters colder and longer. From the drained part of the former seabed, dust containing sea salts, pesticides, and other chemicals is carried out by winds in large quantities to neighboring regions. of course, affects a lot our region, because actually the mortality of child mortality rises, and the maternal mortality also, life of our people, for example, high infant and maternal mortality, 60 per 1,000 live births. Also, the life expectancy is 68 for men in Karakalpak and 72 for women. Also, we have a high unemployment. There are other consequences, of course. The dried bed of former Aral Sea. This is not snow. The picture was taken a few days ago on 5th of April. It's near my university. It's not salt. Believe me that it's not snow, but it's salt. Just there are no such animals anymore. Also, a negative influence to the construction. So I have still 5 minutes, right? Okay. Professors from our Karakalpak State Universities, and in collaboration with the academy, scientists from Academy of Science, carried out the soil researches on 3 places, which shown in that my presentation, first, second, and third. One of them in Nukus, and the influence of the underground salty water to the construction. You see that salt eats even the concrete and the ferroconcrete too. So the level of the underground water in Nukus, you see, we had only very deep ones that goes down, because we had a very dry season since the beginning of 2000s, and in other years we have a very high level. It's an average, but in summer, in spring, it reaches even 1 meter. If you dig 1 meter, you can get even less. You can get underground water. There also a map of saltness of the soil of the Nukus, which were constructed by our scientists of Academy of Science and our professors. The red ones, it shows very bad, actually, soil, where it's impossible even to construct buildings. Also, it's the saltness of the underground water of the Nukus. You see in the red place, it's 30,000 milligram to liter salt. So it's also see what happened to that side of the actually salt eats the concrete, ferroconcrete, but it says it's according to some I had such a salt corrosion develops especially intensively, as Professor Cherkasov from the research of Cherkasov's research. Salt corrosion develops especially intensively at an average daytime temperature above 30 degrees Celsius for more than 160 days or more with a humidity of less than 30%, which is ideally corresponds to our situation. So therefore, in our region, more than 160 days, the day temperature is more than 30 degrees on Celsius and the humidity is less than 30%. It's ideal condition for salt corrosion. And because of this, you see the influence to our buildings. Also, it negatively influenced to the foundations, to of the buildings, to our ancient buildings. Now, because of salt storms, if you go through the wall of this ancient buildings, it pours out because they made mainly from clay, and therefore nowadays they are gone. Also, the walls, it's destroying salt dust destroys that walls also. So what's going on? The first project, it's a Kazakh project, is going to port of Kazakhstan to save and replenish the North Aral Sea, or other way, as they say, it's Kokoral, or north part of the Aral Sea. By 2008, the water level had risen 12 meters above that of 2003. Salinity has dropped, and the fish are again present in sufficient numbers for some fishing to be able. The maximum depth of the North Aral Sea was 48. Nowadays, they say 48 even, because they save all. It's possible for them, because in Kazakhstan, people mainly keep livestock, and which is not used too much water, and all water from Sirdarya they are sending nowadays to save the north part of Aral Sea. In 2008, geological exploration search for oil and gas fields was carried out in the Uzbek part of the sea. The contractor is Petro Alliance company, the customer is the government of Uzbekistan. And now we have a gas condensate, which is actually the smell, people say a smell of oil. So, okay, so they will found the former, on the dried bed, we found the 14th century settlement of Aral Asar have also been found. See the picture from the Aral Sea bed. So because of fluctuated the level of the Aral Sea, as I mentioned it in the beginning, so we have found these historical places. Uzbek side is nowadays we are planting trees to save, at least not to let happen salt and dust storms to prevent. You see pictures how it usually several projects, German or other projects, to plant the trees on the dry bed of Aral Sea. And we are also trying to use water saving technologies nowadays, and also creating small lakes around the Muinak city because of shortage we need. It's the using of water and taking care about the environment. Also, we have to find the middle. So we are also constructing such places to keep the lakes around the Muinak city. Also, it's known for projects. There are, of course, other projects, but nowadays we know the Soviet program of 80s, which was to bring two Siberian rivers to Aral Sea to save Aral Sea, but which was failed, of course, and the Tajik project, which says to bring what was the name of the lake in Tajikistan, to Tajik lake on Pamir mountains to send that water. What's the name of
Ragun?
No, not Ragun. The lake.
Sarez Lake.
Yeah, yes. Sarez Lake, to bring Sarez Lake to Aral Sea. And I mentioned it already about the Kazakhstan project, which succeed, and the Uzbek project to plant, especially, and take care about creating small lakes around the Aral Sea. So it's all the time, and I have just some questions for discussion for our students. I have actually created 2 questions for our students, which probably they will discuss during break. And so first question is, which approach do you tend to believe was crucial on drying up of the Aral Sea? And second question is, which one of the 4 projects on saving the Aral Sea do you think is more feasible from a sustainable development viewpoint? So it's all my presentation. If you have some, here's references. And if you have some, please.
Thanks a lot, Rustam. That was a really interesting presentation. And my suggestion is that we take 10 minutes now. Time is 12:06, so 12:16 we get back. And if there are more questions, and we can discuss your questions as well. Thanks a lot, Rustam, and we'll get back in 10 then. Thank you.
Well, thank you very much. Hope you could see my slides as well.
Yes, yes.
And yeah, most of ideas are already mentioned by Rustam, so I will just make some additions. And as we revealed, that main cause of Aral Sea disaster is overuse of water by irrigation, so artificial irrigation. So briefly about irrigation system. So in Central Asia and in general in Uzbekistan particularly. So it's a quite old history. It's about 2,000 years of use of artificially irrigated. It's a gravity-based irrigation system, and irrigation system. So it's open channels. It's and just partially filled with concrete. So there are high water losses due to evaporation during the hot dry summers, already been mentioned, and percolation of water due to outlet irrigation technology. So according to World Bank estimates, only 1/5 of water for in Central Asia used efficiently. So the remaining are lost. So outdated irrigation system also bearing strong economic losses. So I have some pictures about irrigation system and channels. As you can see, there are concrete channel not used at all. In next is a digged temporary irrigation channel. Also irrigation ditch also causes lost and inefficient water use, water leaking. So you can see pictures of like this. So it's a very common, and I think our students are very familiar with this type of problems. So it's these channels are outdated, built in from 30s to 70s of 20th century. It's already outdated. So you can see that how water is wasted on agriculture. So with these pictures, well, some of you are familiar with this kind of views. And yes, and these are problems. So Uzbekistan is introducing agriculture towards the water saving policy. So if during 20 years, I mean 30 years, or this area of cotton under cotton, which is high water intensive crop, is decreased significantly. And I already give numbers on hectares previous lectures. So we have implemented low water demanding crops to agriculture. And if here you can see this chart, if 1985 in average in Uzbekistan it was consumed more than 22,000 cubic meters per hectares. So now in 2010 it's about half of them, and now it's less. So Uzbekistan is going to more and more to water saving technologies. And water use changed. So yeah, of course. Uzbekistan is biggest consumer of water in Central Asia, but absolute numbers, water consumption decreased more than like 2 cubic kilometers per year from 1980s to nowadays. And so significant money investments by government is putting for amelioration and irrigation systems. So annually, so thousands of hectares of kilometers of channels are restoring by under government subsidies in investments, and different water saving technologies like polyethylene sheets or sprinkling or drip irrigation are implementing for agriculture. And for example, last year, as was in Samarkand region, in total in Uzbekistan, we have faced agriculture faced water shortage significantly, and it was announced that of around 280,000 hectares of all agricultural land, almost 80,000 hectares only in Samarkand region are using drip irrigation, and that system significantly could contribute to provide last year a very hot year with less available water without losses in agriculture yield. So only way on overcome of Aral Sea issue our government see on implementation of water saving technologies on agriculture, doing both, providing both subsidized in charging high prices for water, and for Aral Sea It's our government and society is not putting emphasis on restoring Aral. So we acknowledge that it's a non-turning point already passed years ago. So we working on mitigation of consequence of loss of Aral Sea. And that's all. Probably Rustam could come say additionally a little bit about forestation, big forestation company project of former Aral Sea bed. Now we call it Aral Desert. So government announced a big investment plan on afforestation of 500,000 hectares of former Aral Sea bed to avoid dust or dust removal or pesticides removal by wind from Aral Sea bed. That's all. Thank you very much for your attention.
Thank you, Farhod. Very interesting. And is Rustam ready to respond to the question and also to say something about deforestation?
Oh, I actually have to look.
I have information about that. So I already told that from, I think, 2017, yes, 2017, our new government announced a big plan on afforestation of former Aral Sea bed, and with durable to drought and salt plants, bushes in trees. So it's a really big campaign, and every region is contributing to this project. So from Samarkand, it was sent a lot of tractors, other technicals, people to plant these trees cover, because we realize this is a problem. It's a common. It's not problem of only for Karakalpak region. It's a problem of Uzbekistan. So it's quite successful. This year, I think 2 months ago, they announced they made first conclusions. So already a significant part of former Aral Sea bed covered by forest. So it's a desert forest. It's a saxaulus. I don't know a lot of name. I don't remember a lot of name of tree. So it's a big project, and one of my friends are working closely with that project. So I know it's from inside. It's a really big. I think could benefit a lot. And under this project, so they found out a source of fresh water under Aral Sea bed. So big sources. Probably this is also one of signs of for proof of hypothesis of Rustam about nuclear explosions, water fallout, because they found out huge reservoirs of fresh water under Aral Sea bed, and this is used for already in use for domestic use and for irrigation of these forests.
Should I share my screen to show just?
Yes, please. Please.
Yes. Yeah. Do you mean that picture? Exactly. Okay. Yeah. That shows the places of explosions. It points where it was carried out. Also, the level of Aral Sea on B, you see here, and the Caspian Sea. During it's observed you know, it went down, Caspian Sea level went down from 30s till the mid of 70s. And in the mids, it rises again to some level. It's actually Caspian Sea is situated like, okay, how can I do that?
You can see it.
Yeah, it's situated lower than Baltic Sea level. And the Aral Sea is situated higher, 27-30 meter higher, and Caspian Sea is somewhere maybe 20-30 meter lower than Caspian Sea level. So it probably some water went under the plateau Usturt. This is plateau Usturt, went to, there are some hypotheses, of course. And here it says from 1970, it's dried up already, or 80 centimeter per year, dried the level of, get down the level of Aral Sea. And at the same time, this level of a Caspian Sea, which is bigger, of course, the sea, and its surface level rises up during the almost 20 years also, rises up some 30 centimeter per year. That's the places where explosion is happening. And graphs of fluctuations of the Aral B and Caspian V. Actually, it's Russian letters, which stands B and V. It's different. This is on upright. It's Aral Sea level, and on the bottom is Caspian Sea level. And here is underground. Probably it's not nuclear, as Lars mentions. This is the explosions in Aral Sea. Maybe I translated it the wrong way. Probably, I don't know. But as mentioned, other our members, participants might be nuclear, some of them. Name of the explosion, dates of explosion, around 66, 68, or that period. If you look to that dates of explosions, it says at the same time at the beginning from mid of 60s. So when the Aral Sea went away, and is coordinates of the here. They all situated here in a Mangislak region in Kazakhstan, mainly in Usturt Plateau, which is between the Aral and the Caspian Sea. That's it.
Thank you very much, Rustam. That's really, and I think we check in your sources whether these explosions were. My guess were, but you can check that.
Yeah, it's yeah. Well, yeah. Well.
And one and you and Farhod is to send your final presentations to us so we can put them on the website. Okay, let me just conclude this presentation with a couple of words from my side. And I have a presentation with some slides that will be made available on the website. However, I will only, because we have already spoken, Rustam and Farhod has spoken very well about this situation, so I not so much to add. Slides, yes. I won't go through
We can't hear you.
No.
We cannot hear you. We cannot hear you.
Can you hear me now?
Yes.
Yeah.
Yes.
Okay, I don't know what happened. I just want to show 3 slides from these presentations that will be made available, and you can study it with having with me. I just wanted to show a few other aspects of the Aral Sea, and one is that as Farhod said, that there's not only Uzbekistan that uses water, even if it uses the most water from the rivers, it's also the other countries. Even Afghanistan uses the Amur Darya. So it's a joint problem. And of course, if you want to establish some kind of stable ecosystem on the Amur Delta, as well as on the Sirdarya Delta, the northern Aral Sea, you will need to work together. Let me continue. The second slide I would like to show you is a slide that shows the water needs, that's a blue line, and the water access to water, which is a green line. So you have already sort of crossed these lines. So while the water demand is increasing, the water availability when using the water said that you're already on the negative. But as Farhod said, the water is used very wastefully. And I want to show here one slide, which I think is very interesting. In the longest blue staple there, this is representing Central Asia. And it is a prediction of how the GDP, the economic development could be influenced by different policies in view of the climate change. This is the situation in 2050. If you have a good policy with regard to water use, you could get a very good improvement on the economic development. If you continue business as usual, you will have a very negative, minus 20%, it says. So this is only to show that in view of the opportunities that you have, and that Uzbekistan to some extent has already started to work on to use water more efficiently, you have actually a relatively good chance in Central Asia to use the available water resources, but still have a relative life. So everything depends on how you save water, how you efficiently you use water, including mainly, of course, in agriculture. So this is basically the main thing I wanted to stress, that for the future, it's very much in the hands of your leaders, yourself, in order to create a good situation with regard to access to water and access to clean water. One specific thing, we were discussing pollution of water. One specific thing when you are using a lot of water for irrigation, it may not be that it's the pesticides and the nutrients, general fertilizers that is the main problem. The main problem, which I think you could see in Nukus, is that if you irrigate land and the water is drained back into the river, the automatic result is that you have a higher salinity level in the water, which is in itself, if you drink it, a negative thing for your health. So it's a question of making sure that you have unspoiled water to drink. And also basically unspoiled water for your water-related ecosystem. And that was all I wanted to add towards the end of this presentation. And I'm really grateful to Rustam and Farhod for giving us such a good input for us as well, but also to the students. Any specific comment from anyone before we close this presentation?
Yeah, no, it's no comment. Could you go back to the water demand and the water possibility slide, please?
Because, this one?
No. Yes. This one. And and of course, this is a very informative source, and I believe it comes from what is the source? I mean, the
source of this is the preparations for the Aral Sea program 3, I think the Kazakh Aral Sea program, where they had, and it's Sagit Ibatulin that you may know, that has set up this diagram.
Yes, we know him, and is this generally for the Aral Sea basin or some specific country like Kazakhstan?
No, this is generally for the Aral Sea basin. You can see in the heading there, you have ASB, which is Aral Sea basin.
Okay, because this is very, not only interesting, it's very important for the sustainability and water related experts, and I believe we don't see the dates, the underlined dates, and they say some years, I believe, right?
Yeah, these are years, and you can see that the lines cross each other at about year of 2010.
2010.
Or before, yeah, slightly before 2010, yeah.
Okay, and this moment is the very critical, because before it was, the much water sources and higher resource and very lower demand, and this makes some kind of environmental balance between the water source and the demand. And after the crossing two lines and the ecological disaster, water-related disasters, they will get more sharp. Thank you.
Yeah.
This is a very interesting, and this is only my comment.
Yeah, but the thing is that this does not take into account any ecosystem aspects of the situation, because this figure is only related to the human use, demand, and availability. And if you look at, I think I have another here, there is almost no discussion on the protection of water-based ecosystems in the region. And that water, that if you look at this one again, this is not taking into account the need for water for the Aral Sea, for the deltas, for the water-related ecosystems along the rivers. So this is only a sort of a human, from a human perspective, the human use, the economic use of water. So its situation is actually worse than this.
Thank you.
But okay.
Okay.
I wish you all a good afternoon, good evening, and I look forward to further discussions at the later stage. I'm sure there will be intensive discussions later on. And please send your slides to us. Thank you very much.
Thank you very much.
Thank you very much.
Thank you.
Thanks a lot to all of presenters, and Rustam, Farhod, and Bo. Thanks a lot.
Abror?
Yes.
Hello.